One. Yay. What's the first one? 3, 2, 1, go. 3. So what does that make this one that I made up? 3, 2, 1, go. Ooh, not a lot of people fifth hour talking here. Why? What's 1/3 mean? What's 1/3 actually mean? Cube root. You have the cube root 125 to get 5. Since they're both fractions, then we're all good. It's just, the cube root of 1 over is the answer is 1 over. But what if I did this? What changes on the answer? What if it was log base 125 of 1/5? What's the only thing I have to do? 3, 2, 1, go. Negative. You get it. You get it. You get it. All right? Never mind. I'm not going to say anything. We're going through the same thing right now with the ABers. And see that on the board? What's log base 3 of 3? Apparently it's 7. Anyway, this is a big one. Hey, what's 30 squared? Just trying to climb into your brain. What's 30 squared? 900. So if this was no calculator, what do you think this answer probably is? 3, 2, 1, go. Negative, and then what do you think? 4. Why? Because what's 6 squared? 36. So I was thinking you could surmise that 1296 is 36 squared. Because 30 squared is 900. So, if this is supposed to be no calculator, these are supposed to work out. So that's why you get, 6 squared twice. That's 6 to the 4. But it's negative because of the flip. Kind of a big aggressive number there. This isn't that bad. You were supposed to do these ahead of time. So what's this one? 3, 2, 1, go. 7. Come on. We can't think a little bit. 2 to the 6th, 2 times 2. Keep doing 2 times 2. You get to 64 is 2 to the 6th, and then you need one more. What's the next one? 3, 2, 1, go. 2. What's the next one? 3, 2, 1, go. Log base anything of 1 equals 0. All right? It's all good. It's all easy. All right. Let's see if you can fit this word in here. What is the relationship between these two? Oh, I ran out of room. Okay. When I say inverse, you say split XMI or domain and range exchange. And then, input, output, when we have ln, actually, yeah, you ready? Output, say it. Well, what do you think you should do? Output, input, because really you could think about this way. Because if I plug in 0 here, e to what power? E to the 0 power equals what? What's e to the 0 power? 1. I don't do that. I can actually, my thinking is that though when I'm filling out my chart, I can do that because that's what I'm thinking about. And then what happens when I output 1? What's my input? What's my input? E. What is E approximately? We should do squigglies. 2.718. I can only fit 2.7 in there. Oh, sorry. 10. 2.7 comma 1. And then if I plugged in 2, now we're getting into E squared. I think it's 7.4 if you typed it on your calculator. Just know it's not 9. It's probably a little before 8, maybe 8-ish. But I think when I looked at the notes, I didn't even type it. I just looked 3, 4, 5, 6, 7.4, 2. And then as you keep going this way. And then output -1, what's the input? That's 1 over E. Honestly, you wouldn't be marked wrong. It would be, it just put 1 over E. It's close to 1/3. That's good enough for me. It's 1 over 2.7. 1/3's a number we know. It's fine. It's okay. And then 1 over E squared when I plug in -2. Just write that and understand, okay, if it's 7.4 over here, then it's 1 over 7-ish over here. It's good enough. Just means it's closer to the y-axis. Sorry, I knew I was going to do that. I was trying to catch myself. But we're never going to hit that x-axis, so we have an asymptote. One more time, when I say inverse, you say, so -2, -1, 0, 1, 2, 1 over 7-ish, 1 over e squared, 1 over e, 1, e, and e squared, right? And then those approximate decimals. So now we have, and on the quiz Monday, I did tell, I want axes there. We have enough space to graph these. I want everyone's graph to be in the same spot. So 0, 1, 1, comma, e 2.718, 2, comma, I think it was 7, 1, 2, 3, 4, 5, 6, 7. And then over here we have the small and the small. Right? And this one has a horizontal asymptote at that axis. Okay, so what's the domain of this logarithm? I almost said the wrong thing. That's why I had to check my brain. We got a problem. We can't have 0 as an output value, nor negatives. Hey, that happened to be the range. That's why these are inverses, or that's a relationship, let's say, not y. And then the range is all real numbers for this. It is. You cover everything. My infinities are terrible today. I don't know why. Having an infinity struggle. All right. And this does rise forever. And I will tell you, when you graph a log and an exponential, I said this the last hour too. If you put them in a graphing calculator, it's actually really hard to tell which one's which. Doesn't it look like this is kind of asymptotic behavior right here? Right. Doesn't it look like this is kind of asymptotic, but maybe with the vertical? So it's really hard on a graphing calculator. That's why we barely even touch them when we graph logs. We don't even talk about it. It's 3 simple points and then attributes. So be careful. That's what I have students do, crazily. This is all real numbers. And then asymptotes. We got some people, and apparently Mr. Samuel says this is about to yell about how people don't have vertical lines as x equals. I almost screwed that up. Horizontal lines are y equals. Still got ABers that can't do that. Can't make that distinction. At this stage of the game, it's inexcusable. All right, and then end behavior as opposed to asymptotic behavior. When you look at the end behavior, that's going to the right, the end of the graph. There's only one end. And this end is when you go off to infinity for x. Very slowly, we go to infinity for y. Oh, and I did cover this with the other people. The graph on the right, what's its concavity? What's its concavity? 3, 2, 1, go? Up. What's the concavity on the left? So when you find the inverse, it does switch concavity, but they're both increasing. Now, maybe it was developed this way, but to really see that it's concave down or increasing at a decreasing rate, you need, I should be pointing this out here, you need the average rate of change between these two and then compare it to the average rate of change to these two. So what you're doing is you're moving right on the graph, all right? And what happens is the slope of this line is steeper than this one, so the slopes are getting smaller. That's at a decreasing rate. Whereas when you find the average rate of change from here to here compared to from here to here, that second average rate of change is getting steeper. So that means it's increasing rates. Makes sense? We also did this. We said tangent lines. Slope of that tangent line, slope of that tangent line, slope of that tangent line. Those tangent lines are getting steeper. So therefore, it's an increasing rate. So those were some previous things, good development, good things that they were asking you. I know, squirrel. I just went off of this on a random thought. And then this one is, you got to be careful. This is special. You're approaching 0, that asymptote, from the right side. That was the plugging in the small numbers just right of 0. And that one goes off to negative infinity. All right. End behavior and asymptotic again. Well, this is both ends. I kind of disagree with that, but because this is still end behavior, left end. Okay, fine. You're approaching an asymptote, and that's approaching 0. Right end. So these are actually 2 end behaviors. I think in a way. X infinity. Sorry, couldn't think there for a second. And that one is infinity. All right, and then the intercepts, this one is 1, 0, whereas this one is 0, 1. And we get all that too. So really hammering the inverse point. Uh-oh, where's he going? Okay, go ahead as he's sharpening his pencil to write these down. It really is all the same that we've talked about before. I'm going to take a walk around the room. He's kind of cool getting a November snow. Fourth hour. They don't have a pool. Talk about pools. Who has a pool? Nobody? Did you close it yet? Of course he did. I closed mine this week. Unfortunately, I opened up was I so lazy that it was last Monday? It was green because I've been letting it go for a while. So I had to run the filter to ungreen it. And I finally put the actual tarp on, but I kind of half did it. Then the filter stayed on. So what happens is the water starts circulating. It jumped over the side once. Now all the water is pulling my. So I'm gonna have to redo it all. It's not really a big deal, but it's sinking fast. And it's raining, snowing. But I'm in denial. I don't want to close the pool. Okay, so this is all inverse notational stuff. The domain of one is the range of the other, right? As you read this, correct? I think we've hammered this point down all week, correct? All right, 1, 0, 0, 1. This is interesting to note here that, even the exponentials, that b value has to be greater than 1. It could be in between 0 and 1, but it can't be negative. If you want to try that. As a matter of fact, I'm curious. Let's see what happens. Let's see what happens when this will take a half hour. I'm going to show you what happens when you put a negative base in. It's really weird. I think I've done this before. The graph is nuts. Okay, so y equals, and you got to do it like this. Ooh, we got some, what do you call that? Regression stuff there. What if you did a negative base raised to a power? Is that an exponential graph? You're ready to be like, what? Zoom standard 6. Does the calculator even do it? That's weird. I don't even get a picture. Input, say it. Did I have this turned on? It should be on. It doesn't even graph it. That's wild. I'm actually stunned. I thought it would at least draw a picture. Because I could plug in 1, input 1. You know what? You can't take the square root of a negative, right? So I can't plug in 1/2. That would be an undefined real number. You know what I'm saying? So that's why it probably shuts down. So that just goes down to my point. I thought I got a graph from that before. You know what? I have an idea. Let me see something here. Oh, I hit the wrong thing. Let me see mode. There is a plus BI mode. I wonder if that changes anything. I don't know. Just playing around. This is kind of embarrassing that I have this on the video. Nope, doesn't even do it. Okay, so, all right. There is an imaginary mode. Then it allows you to deal with imaginary numbers and get output values. Did you know that, by the way? Did you know there was an A plus BI mode on your calculator? Because then you can do this. This is now totally right. Squirrel, all right? Square root of -4. Booyah. If you were in an A plus BI mode, it would say error, right? See that? Now you can do I numbers on your calculator. One more thing that's not good with logarithms. This is bad. Another thing that's bad is log base 2 of 0. And this leads to our domain issues. These are not possible. Or sometimes I just do this for laziness. I'm not sure. Null set, I think that's okay. But anyway, those don't work. So that creates our domain issues. That's what all this rigmarole is here. B can't equal 1, otherwise nothing would happen. 1 being a base, just 1 any power is 1. Blah, 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 blah. Now this is a lie because Monday I changed. I just did, what is that the noise for? Logarithms, just where are the positions, all right? So I didn't even do this on Monday, but didn't you do this on probably Wednesday? I don't know which day. Did you have to graph this? And then did you graph a vertical asymptote, I hope? All right. So I think we've done this to death, and this was from your homework. You actually were supposed to fill this out already, so you already know these things, correct? We're good? So can we graph? Input, say it. Output, and then I'll stop spinning it here. Okay, and then I'll just pretend. And you know what we did? We just did 1 and we did 4. Is that good enough? Okay, 1. And then the last one's good. Input. You know what I'm going to input though? I'm going to input a naughty value. What's the naughty value that I'm going to input? What do you think? What's the what value doesn't work? -2. That's our starting point. And then I am going to be a lazy. I don't know if this is mathematically, syntactically incorrect. It's not possible. It doesn't work, doesn't evaluate, whatever. But what does that mean? We have there, everyone. 3, 2, 1, go. The vertical asymptote. So this is the y-axis. So I have at x equals -2, the vertical asymptote. You don't have to do this as a student. This is not mandatory. That's my thought process. And then I plug in, what do you think the next one I plug in is? -1. And I am going to put it in the middle because I do want to show a small value and a not really large value, but a large value. Okay, what's -1 plus 2, everyone? 1. What's log base 3 of 1? 3, 2, 1, go. 0. What's 0 minus 4? So it's -1, -4. There's your 4 down. And then there's your 2 to the left. This 1, 0 point's supposed to be there. It's now over here, but then also down 4. Were we talking about food in this class? Was it this one or last one? I thought we just asked, what's your favorite place in the area, right? They just said no. Don't listen, all right? I think I'm going to Pops. I just thought about, no, you know what? I own stock in Portillo's. So I'm going to go all the way to Portillo's just to make my stock price go up. All right, and then what should I plug in next? What do you think? What's a good number, not fractional? What should I plug in next? What number should I plug in for x? Not 0. No, that doesn't work. Look at the base. 1. Why 1? What's 1 plus 2, everyone? What's log base 3 of 3? 7. Look at the board. AB. What's log base 3 of 3? 1. I'm making fun of you because we had a quizzes today in AB, and 7 of you missed log base 3 of 3. 7 people. What am I dealing with? I don't know. Anyway, so 1 minus 4 is what? I think, are they doing it on purpose? Do you guys know? Do you know someone in the class that does it on purpose? Do they miss them on purpose just to drive me nuts? Log base 3 of 3. Okay, what would be the next one if I made you do 5 points? What do you think I'd plug in? 7. Oh, and he was nervous saying that because, all right, 7. It's right, because what's 7 plus 2? 11. 9, sorry. And then what's log base 3 of 9? What's 2 minus 4? -2. 1, 2, 3, 4, 5, 6, 7, comma -2. And then someone asked me, do I have to do this point? And I almost felt like, you know what? Now you do, and I might make something up on the quiz. What should I plug in here so that I get 1/3 in here? It's really not that hard of a question. What do I have to plug in for x to get 1/3 in there? Negative. We'll start with that. What do you think? 1 2/3. It really is easy to think of it that way, because then that leaves a third left over on that too. So then what's log base 3 of a third? What's log base 3 of a third? -1. What's -1 minus 4? -5. And it's nice to see that point. -1 2/3 is really close to -2. And it's that dropping point right there. So yeah, this is what we got. Even to find the x-intercept, it would be tough. I don't know if I could get it to be, can I get the, oh yeah, I just have to get that to be 4. What's 3 to the 4th power? What's 3 to the 4th power? 81. So how do I get 81 in there? I plug in what? 79 comma 0. Got it? You ever see how fast I got the x-intercept? So way out there. It's way out there. All right? I like that discussion. Okay, all right. So what's a domain? It is -2 to infinity. That was the first bell, right? I think we'll get there by the second bell. End behavior. I guess they're saying the right end. Yeah. Not guess. It is. There is only one end. It's to the right, and it says x goes to infinity very, very, very slowly. You do go to infinity. And then we did analyze what the no, wrong. The vertical asymptote. Too many words in my head. And then the limit at the asymptote. Be careful. We have very specific directions on that when it comes to the quiz. What's the asymptotic limit? Okay, this is the asymptotic limit, and you're right of -2, and that's negative infinity. That's this part of the graph down here. You're analyzing that part when you're very, very close to -2 for an input. Input output, I'm sticking with that comment you said about input outputting, just took care of the whole multiple choice section. I do it though too. It is true. Input output can really handle everything. This is why I actually did this one, because you got to recognize what you have here. But what's the first naughty value? What's the only naughty? No, there's many. There's an infinite amount of naughty values. But what's the one? I just said it on accident. 1, because 1 minus 1 is 0, and that doesn't give me an output. So this is the vertical asymptote, x equals 1. Really easy. This isn't rocket science. Okay, and then 1, 2, 3. I want this to be, so what would I plug in next? I want this to be 3 on the inside. What do I have to do? What do I have to plug in to get 3 on the inside? -2. 1 minus -2 is 3. Log base 3 of 3 is 7. All right. -2 comma 1. -2 comma 1. All right. All right. And then how do I get 9? What do I have to plug in there? How do I get 9? -8. I want nice numbers. 1 minus -8 is 9. Log base 3 of 9 is 2. So -8, 1, 2, 3, 4, 5, 6, 7, 8, comma 2. And then the last thing, that's really not steep. And then the last thing, wrong. I don't want any more on that side. I want this to be 1/3. So what do I have to plug in? 2/3. And then 2/3, 1 minus 2/3 is what's log base 3 of 1/3? -1. So 2/3 is close to 1, comma -1. There's that coming down behavior to the asymptote. Break that up and then come straight down. All right, so the domain is actually, so what did we have? We had a anyone? Y-axis reflection. Okay, so if we had to denote that, and then it's actually 1 right. So I'd have to pull out a negative and then see x minus 1 on the inside to see 1 right. So end behavior, this end goes to the left. So my end behavior is as x approaches darn it. I didn't make it. I think this is exactly where we were last hour, though. I remember landing. The bell rang right around here, and then the last one's like so fast. Then the asymptotic behavior, it is different since I'm on the other side. It's x arrow 1 from the left. So it's 1 negative. I'm on the left side. This is just notational math. It still does go down. If I had this flipped, then these would be changed. If this was flipped over the x-axis as well, this would be positive, that'd be negative. I think we can see that, all right? And that's the only time that happens. But you're putting your stuff away because this last one's easy. What's the domain? Well, first of all, we know where it's located at least where the bad value is. What can't I plug in for x? 3. And is it to the right of 3 or the left of 3? That's good. Well, just think about input output. Can I plug in 4? Can I plug in 1? it's over. The domain is 3 to infinity. The first question, yes. The second question, no. Right? That negative does flip it over the x-axis, though, not the y. So it just asks for the domain. So not too far off. All right. Been a pleasure.